In this example, we have one of the typical examples from algebra. So we need to solve this quadratic equation by using the formula of coefficients in order to determine the roots of the equation. To see the effects of the coefficients on the solution, we have three sets of the coefficients A, B, and C. So at the very beginning, we import the function square root because we need the square root function for this code. And usually the all import statements are set on the top of the script or the script file. The second section is the input. So because if you define the coefficients A, B, and C as constants, so you have to change them every time in the code. But input gives you the flexibility to introduce them during the runtime at each run. S is the quantity under the square root. And we define it here just in order to make the code more concise, smaller, because it is repeated in multiple lines below. So instead of repeating the whole formula, we can use one variable to represent the value of the quantity under the square root. Then the first condition, if the s is less than 0, it is recommended that always make the special conditions in if or else if, while leave the more general situation for else. So if deals with the negative values of s, which apparently will lead to complex roots. So for that reason, I make the calculation of x1 and x2 as complex values by using complex function. It is the conversion function, complex conversion function, which we studied before. And then after calculating x1 and x2, we print the values of x1 and x2. Now, elif or else if s equals to 0, when there's no value under the square root, and we know that there are two equal roots, two equal real roots in this situation. So we can calculate only one value for x, and then we print that there are equal roots and print x. Finally, as I said, we leave the general situation or the most common situation that we have always real roots to the else, because this is the only remaining situation in this case. And we calculate x1 and x2 according to the equation and print the title real roots with the values. Now let's run the code and see the results. We get the prompt to enter the value of a. So I will take the first line, 2, 2, 1. And as we see, we have complex roots. Let's try the next one by running the code again. Of course, we run the code by pressing F5 4, 8, and 3. In this case, we have real roots. So that means the first condition, s less than 0, and the second condition, s equals to 0, were false, and the only solution was the real roots at the else statement. So for that reason, the else statement was executed. Finally, let's run the code again. This set of coefficients gave us equal roots. So this means that in this situation, s was equal to 0. The operations related to the second conditions were executed.